Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Often a gearbox and occasionally a high voltage transformer, and the whole thing sits on top of a tower, which is mostly there to keep the blades from digging a hole. We tend to class turbines by their power output, and hence their physical size. Wind farms might use many sub-megawatt turbines, each producing 400, 600 kilowatts each, or a few multi-megawatt turbines producing maybe up to 3 megawatts per unit. Apart from physical scale, they are arranged a bit differently. So let's start by looking at a typical sub-megawatt model. Turbines of this type are typically 25 to 45 meters tall, and at the base you will often find two doors. The lower door takes you into a secured compartment where we have a high voltage step-up transformer. The generator at the top of the turbine is producing about 690 volts, and this transformer converts that into several thousand volts to send it more efficiently to the substation. The main entrance to the turbine is at first floor level, and there we find the control cabinet and the base of a ladder, or a series of ladders. Often in these smaller turbines, the ladders run to a series of platforms and they change sides at each platform to give you a rest area and a bit of fall protection. Platforms are generally just wooden discs suspended inside the tower walls, and they might have a trapdoor or a set of guardrails and a gate, depending on how the ladders are arranged. The main run of cables goes up the wall of the tower, dodging past any intermediate junctions, because obviously the towers can't be delivered in a single 40-meter long section. They come in 20-meter long sections. They're bolted together with a lot of nuts and bolts. But as we move higher and higher through the platforms, they're getting slowly narrower and narrower, so the ladders are getting a little bit closer together. But eventually the main cables stop being attached to the wall, and they hang freely in the center of the tower, so they can twist as the nacelle rotates to face the wind. If they twist too many times, the nacelle will spin itself around to remove the twists. But as we move up, now the cable goes through a hole in the center of each platform, and at the top of the tower we have a steel platform with a sealed trapdoor, which we call the yaw platform. Just above that we have the yaw ring with the bearings that allow the nacelle and the rotors to rotate around to face the wind. And this sealed platform acts as a bit of fire protection, also avoids people falling back down the tower, because at the top of the nacelle we simply have a hole through which we climb. And the nacelle in this case is a vaguely tapered tube. At the back we have the wind sensors, which give us speed and direction and allow the turbine to face into the wind and to change the angle of the blades. The nacelle itself is just a fiberglass tube. At the front we have a similar fiberglass cowl protecting the hub, which is a steel casting on which we have bolted our 3 blades, and the blades can turn or pitch so that the angle they form with the wind can be varied. Out of the back of the hub we have a shaft which leads into the gearbox, then a high-speed shaft through a brake into a generator, and that generator then supplies the electrical power, as I say, at about 690 volts all the way back down the tower to the base. And right at the back we have a cooling fan, as we're generating 500,000 watts of energy inside the nacelle. Some of that is wasted as heat, and without an efficient cooling system there is the potential for the turbine to catch fire. Now, the layout of a larger turbine is turbines in use today are horizontal axis machines which have a 3-bladed rotor spinning in a vertical plane attached to the front of a box which we call the nacelle, after the fairing around